this exercise, this equation that we have now does not require us to. Okay, we only have the function here, no, at f of x here. So no more derivation, unlike the Newton's method or the modified secant method. So we only need the original function here. So the original function in this case remains here, no, in solving for f of x sub n, and which is inputted at this side and this side, and the value of f of x at point, or the value of the function at point x sub n plus that slight movement, no, using the perturbation fraction, which is this one. Yun. We in this case na, so that's why we have separated the columns for this, the product of the x of n and the perturbation fraction, this side, and was further added back into the original value of x. And so later, this slight movement to the right now, because that's what happened when we introduced the perturbation fraction here. So we've added a small increment of x value to move further to the right from 20 to 2 point, or 20.2, and then we just plug in this value here into the original equation. Okay, so the new solution x sub n plus 1 is based on this equation here. So still have uh, the increment, no, as the result of the perturbation fraction, and then the value of the function, and the new value of the function after that slight movement. Okay, so I hope that clears up things.
Yes po, thank you po.
Okay, any other questions before we proceed? Okay, so if none, then we will go through the modified Newton's method for evaluating equations having multiple roots. No, so this approach was first published by Ralston and Rabinowitz in 78, and here they introduce a new function u of x, which is somewhat similar, no, to this expression here from the Newton's method. So what they did is that, so you try to compare, no, the difference between the original Newton's method and the modification that they've introduced. So it's like something that looks like a chain rule in calculus, no? So, but in this case, they have instead the u of x here and the u prime, or the derivative of that new function they've introduced here. So that means the f of x here will be or the f prime will be somewhat repeated, no? Because we have the f prime here and another f prime here. So anyway, to go through this, so we have to first evaluate the derivative of the function u, and so from our formula in differential calculus, we have the following, no? Okay, so the numerator times denominator minus the right, so denominator times numerator times derivative of the numerator minus the numerator and the derivative of denominator divided by the square of the denominator. And when we substitute that equation, we can have it simplified into this form. So notice that it has still that sort of similar structure to the original Newton's method, where the new solution will be based on the previous solution or approximation. We're just adding or subtracting some components here. So will go straight now to the example to further demonstrate this. Okay, so using the modified Newton's method, we want to work on the following equation. So this is x cubed minus 5x squared plus 7x minus 3. And then we'll evaluate this at point at the value of x at 0. So from this point, I've already plotted this using a Wolfram alpha to give us an idea that this function has two solutions, no? So we have here close to 1.0, and the other one is at around 3.0, no? So we'll check later in our approximation. It will fall on that exact 2 points. Okay, but first we're gonna uh, evaluate that function using the standard Newton's method. Now, so since we have the function here, we'll obtain the first derivative, which is 3x squared minus 10x plus 7. And then going back to the standard Newton's method, so we have the original function here in the numerator, and the denominator here, and the derivative here in the denominator. And then we have to plug in all these values using the initial guess at x is equal to 0. So I've already tabulated a solution for this, and so we have the following. After 6 iterations, we can see that the solution converges, no, to a value close to 1. Then again, this is the case, or the when we use standard Newton's method. Now, using the modified Newton's method, we have to solve for the second derivative, which is 6x minus 10. And then we make use of this into the previous equations. So this is a rather a lengthy one, but if we go back to the following expression, so we have the original function here, the first derivative here, the square of the first derivative minus the original function again, and then the second derivative. So in this example, right, so as you can see here, uh, this has been reduced or presented as it is, no? So kind of the same thing, no? So this is after three iterations or so. You can see that in the modified Newton's method, the convergence rate is somewhat faster than the standard one, no? Now, the thing is, if we can recall from the plot, we actually have two solutions. So we'll try to evaluate the other solution, but coming from the right side, no? So we've seen that there is a solution at around 3.0. So we use a different value of x, no? So the new guess will be x is equal to 4. And we've done the same for both the standard method and the modified Newton's method. And you can see na in both cases, the solutions converge, no? At some value at around 3. So we have the two solutions for this at 1 and 3. Right, so for your exercise, you're gonna extend this and check to see if we can lower the error rates further. Okay, so I'll try to open first the uh, spreadsheet example for that. Okay, so here is the same problem implemented in a spreadsheet. So, and so we have for this case we use the standard Newton's method, and that's it. No error rates. We have the same formula, and then we could just convert this to percent values. So as you can see, we've reached convergence, no, for 1% error in 7 iterations. For the modified one, then we reach convergence faster, no, in just 2 iterations. Yes, any questions so far?
Sir, yung x plus pa sir ay xn plus 1, correct?
Yes. So to avoid
Oh, got it, sir.
confusion, I guess
Thank you.
we can change this notation.
Oh, thank you, sir.
if it helps, no? So, okay, so that was supposed to be your exercise anyway. So, yun, so for this, no, yun, so at three iterations or four, then we were able to reduce, actually two iterations, the error rate to below 1%. Okay, so can you guys work on the same but using x is equal to 4 and check to see how many iterations will be required to reduce the error rate to that below of 1 ppm. Okay, so I posted the problem in the chat box. No, kindly check if you can work on the same. So the using the modified Newton's method. So you'll work on the same problem, but beginning with x is equal to 4 to check on how many iterations does it require to reduce error rates to that of below 1 ppm values. So, I'm gonna highlight the solution here if it can. Okay, so if you have your answers already, you can post it in the chat box and please share with us how many iterations we able to uh, achieve that error below 1 ppm.
Iteration number 6 po, sir.
Yes,
Iteration number 6 po, sir.
6 iterations.
Yes, sir.
So for the others, fifth. No, so let's try to extend this thing. All right. No, so notice that jump from 500 to less than 1 ppm in just after one iteration. Okay, so that's it. No, since you have the template already, then we will have another preset as well now for the modified Newton's method. Okay, so is this clear for everyone? Are there further questions, concerns, or clarifications?
Iteration number 5 po pala, sir. Na ano ko, na-offset ko yung ano ko, error by one line. My bad.
Right, so it's okay, no? So anyway, it gets further confusing, no, when we're implementing the same for different flat platforms, no, like in the case of if you're programming in Python and then you switch to, let's say, doing this in MATLAB. So the reference points of 0 and 1. Then we have to take note of that as well. So the idea here is the number of operations that we need to perform, no, to for us to be able to um, home in on a solution. Okay, so that's pretty much it, no, for our discussion today. So before we end, I will share with you some codes actually. And so this is the implementation of yun. So this is the implementation of fixed point iteration in Python. So I'm using uh, it's called the Collab notebooks. So this is web-based, actually provided by Google. You can store all your simple Python-based programs here. Actually, some more advanced users can use this in coding intelligent systems or AI. Albeit the memory allocation is somewhat limited in this case. No? So and I'll just try to demonstrate some of these. And then, of course, you have to connect. And so while waiting for the system to connect, no? Yeah, so it's already connected. And you can see here that you have a limited memory allocation here because this is a free version. The paid version provides greater amount of computational power available. Anyway, but the idea here is that you can implement simple programs like this one. So let's try to, if you try to run this, so let's just, oh, okay, so I'll try to run this again. So I'm just choosing arbitrary numbers here, no? And then check to see how the code works. So we were able to find the solution, no? And this is the desired outputs. So these codes are based from online sources. So I've noted here the source. You can check, do a quick search and check for the source here. And the idea is you can create simple programs in Python, and you can actually share this, no, with your group. So you can I'll actually share this one using this link, no. So okay, so you can check in the chat box uh, the links for some of the codes that I was able to source online, and kindly check if you can no, if you can access those codes. Okay, so please check all the links for the five codes I provided, because I won't be sharing this one in our classroom page, no. So only for this session. Once you have it, you can bookmark or copy the contents. Uh, but in your respective group projects, then you're gonna have to create a different program actually. All right, so you're gonna have to create a different program. Well, the structure can be somewhat similar. Of course, the algorithm will be definitely aligned or the same with the ones we've discussed or the one presented in these sample codes. But there has to have a different presentation on the way you are to program or create the codes, no? And this will be the basis actually. So you have to create your own code, no, not copy that one. So because I already sourced the most common references online, so I can check, no, your outputs based on the originality. So for your first group project, you'll be working on the methods for identifying roots. So you have to code one example for bracketing method and another example for open method. So you just have to choose any of the methods provided. So at least one bracketing and then one open method. The specific instructions for each will be posted later. No, so I will post the specific instructions for the group project. So it would be, I would appreciate if I can have the list of the groups sooner, so as to consolidate the I don't know the group grades once I've checked the codes, no. Right. So kindly check first the sample codes if you can access all of the 5 examples.
Pwede po,
Yes.
pwede po, sir, pa-check ng lower part ng code.
Okay. You mean the one I'm projecting here?
Yes, sir.
Okay, so this is the output. Anyway, you can copy naman the entire code, no? And then create your own file. So this works exactly the same as uh, Google Docs, no? In the sense that if you're working in groups, you can share the same file, and then your group can work collaboratively in the same file. No? So this is in this case, I shared with you the link as a viewer only. No? So you can copy the entire thing and then execute the program as your own file. No? Create your own file having the same content, and you can run it through your respective Google accounts.
Got it, sir. Thank you, sir.
Okay, so are all of the 5 codes accessible to everyone? Can you see a show of hands if you were all able to access all the 5 codes? Okay, please see to it now that you have access the same. Yes. Ay, sige, sige. Anyway, yan. So, please check no the links, because again I will not be posting these links later. So only the instructions for the group project, and of course the usual presets. Okay, so for those of yet to review or practice some programming, there are several YouTube clips or other online sources like this one. Anyway, this is just around 6 minutes, so I'll just play this anyway, and we'll share the same link and after this session.
So in this video, we're going to try and learn as much Python as we can in 5 minutes. So let's get started. So to comment in Python, we use the hashtag, and then whatever we want to say. We can use multi-line comments with 3 double quotes.
And welcome back to this U.S. Open office plan.
Miller just lobbed a message way over Jones's head using some technical
Double quotes. We can put in our comments here and then end it with 3 double quotes. Of course, we can do addition, we can do subtraction, multiplication, and division. We can also store data in our program using variables. So to create a variable, we give it a name, we set it equal to a value, in this case a string called hello world. Strings in Python use either double quotes or single quotes, the choice is yours, and there is our variable. We can also store multiple strings in a variable if we want, using something called a list. So I could create a variable called b and say I want to store 2 strings this time. Let's store the word hello world and the word Francis. Hit enter and we've stored that in a list using 2 square brackets to say that we want to use a list, and we tell it all the items we want to store separated by a comma. To get an item out of a list, we need to know its position in the list. So this is position 0 and this is position 1. So if I said b square brackets 1, it'll print out the item in the list at position 1. We can also add lists together, so I could say b plus a new list 1 2 3 4 5. Hit enter, and now we have a new list with 2 strings and 5 numbers in it. That's another great thing about Python lists. They automatically resize and they can store any data type you want or multiple data types. Next, we're going to learn about dictionaries. So dictionaries are just like lists, except to access data in a dictionary, instead of using its position in the list, we need to use its name. So every item in a dictionary has a name, which we call a key. So I'll create a variable called C, and we use 2 curly brackets to say we want to create a dictionary, and its name is going to be fav color, and it's going to give us back the string hello world. So we hit enter, and now if I say C, use the square brackets again, and I put in the word fav color, we get the word hello world printed back. That would be called an associative array in other languages like PHP, for example. Finally, we have sets. So a set is just like a list, except it doesn't have order and it doesn't have repetition. So to create a set in Python, we create a variable. We use 2 curly brackets again, but we don't use the colon when we're creating a set. We just give it a list of values, and I'm going to repeat some like this. Save that, and now we want to see our set. You can see there are no repeated values. Everything I repeated just was ignored when we created the set. We can also add logic to a Python program. So if we want a certain action to only happen in certain circumstances, we would say if, say 1 equals 1, then we will print out the word of course. And we run that, and you can see it prints it out. If I said 1 equals 2, obviously not, because that isn't true, and you could see that code never got run. So Python has equals operators, it also has not equals, it has greater than, less than, greater than equal to, less than equal to, all of the operators you would expect. Python also has Boolean data types, so if we say the word true or the word false with a capital letter, and we can also use Boolean operators, so I could say true or false, and that will give us true. I could say true and false, and that will give us false. Python also has loops, it has while loops and for loops. So we have a list here called B, and we can loop over every item in the list using a for loop. So if I say for item in B, because that's the name of our list, and we're going to refer to every item as item. That's what this variable does. So if I wanted to print every item in the list, I would say I want to print item. Run that, and you can see it prints the 2 items. For loops can also use numbers, so I could say for I in range, and the range is going to be 0 to 10, and I'll say print I. This will print out the number I 10 times, as you'd expect. We also have while loops, so I could create a variable called x and set it equal to 10, and I could say while x is greater than 0, print x. And then I'll also say x minus equals 1 to subtract x to prevent an infinite loop. So I run that, you can see it counts down from 10. Python also has what are called exceptions. Whenever something goes wrong in your program, sometimes the program doesn't have to crash. Sometimes the error can be caught as an exception and can hopefully continue to run. So an example of an exception is we go back to our list called B, and the first item is called 0 and the second item is called 1. But if I was to put in the number 2 here, you can see we get an index error. So I can say try, and I can try to print an element from our list that doesn't exist. But of course it doesn't exist, so it's going to give us that index error. So what I can say is except index error, and I can say item not in list. So you can see we get this text instead of this big error message now. Python also lets us create functions, so if we want to run some code multiple times without typing it in again, we can create a function. So I'll call it func, and it's just going to print hello world. So now if I run func, it's going to print hello world, and I can run it twice and it's going to print it twice. So that is a simple function. I can also create objects in Python. So we would use an object for object-oriented programming. So say we wanted to create an object for people. We might create an object called person. To do that, we would create a class called person, and we create a special function called underscore underscore init underscore underscore, which is called a constructor. And we pass it the variable self. Every method in a Python object starts with the variable self. So a constructor is a function that's run when we create our object. So I'm just going to print new person. Now we've created our person class, which is the blueprint for our person object. So I can create a new person object by saying p equals person, just like that. And you can see our constructor was called when we created the object, and it printed new person. And there is our person object. We can also use inheritance because that's one of the core concepts of object-oriented programming. So say I wanted a more specific class called Francis. Inside these round brackets, I can say person. That will mean I can use any of the methods and functions from the person class. So in this class, I might say my name is Francis. So what I can say is super.init to call this special init function. Now I have my Francis class, and now if I was to just say f equals Francis. And finally, we're going to go over modules. So in Python, we use modules because we don't want to type everything over and over and over again. So if I import math, that'll import the Python maths library. And if I say print math.py, it prints out the value of pi because my program didn't know that until I imported the math library. So that's a really quick overview of Python. There's a lot of stuff I didn't get to cover, but we're going to cover that in separate videos in much more detail. But that's it for this video. Don't forget to like, comment, favorite, and subscribe. Don't forget to follow us on Facebook, Twitter, and Reddit. But that's it for this video, and I'll see you next time.
Okay, so I'm gonna share also the link now for this clip, and there are further references that you can check later. Like you can see some other video lectures, more in-depth discussion on Python programming ranging from 4 hours to 8 hours. So if you have the time, then you can brush up your programming skills using those video lectures. Okay, so yun. So again, for the first programming activity, then you will create a program, no, using either using one bracketing method and one open method. You can choose in any of the topics we have covered. So I'll give you guys around 2 weeks, no, to work on that. And again, that will be a group project. Now next week we will cover Gauss and Gauss-Jordan elimination for matrix operations, no. And the week after that will be week 8. We will start checking on your proposals for the final group project. So hopefully by that time, 2 weeks from now, you would have come up with 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 your project ideas. So that's the project proposal presentation, week 8, no, on October 18. If you haven't done so, please discuss among your members or group mates on the possible way forward, no, for the group project. So I will be sharing some guidelines on this one also, at least for the project proposal template. And again, as early as now, you can check the IEEE conference paper format, which you will follow in the final project presentation on week 15. So that's around that time you would have completed all the deliverables for the final project presentation. Okay, so are there any questions, concerns, or clarification so far? Okay, so again, I will be posting later now the instructions for the next for the 3P sets related to our topics today, and also the instructions for the first project requirement. Yeah, so if you have further questions, you can just send me a message through the Gmail chat functions or email, no, either of which, and then I'll try to address your concerns whenever I'm available. Okay, so if there are no further questions, then I'll see you guys next week. No, so that's it for from me this afternoon. I'll see you next week for our discussion on the matrix operations, and that's it. No, and have a great week ahead. And thank you, and stay safe.
Sige po, sir.
Thank you po.
Thank you po.
Thank you and goodbye po, sir.